Hi everyone, and for today's PCON e-learning, my group consists of Kdiv, Deepthi, Shaun, and me, and we'll be talking more on various design of the flow meter. At content, we'll be covering more on the different types of sensor, mechanism of flow sensor, importance characteristic, application, and lastly the reference.
Sensors transmit measured environmental changes to a controller, which then signals an actuator to maintain a design set point. In other words, flow sensors monitor the flow of fluids. Flow can be calculated by multiplying velocity and area. Flow sensing involves fluid dynamics and exploiting different physical phenomena for flow sensing, for example, the temperature of the surroundings and motion.
Now we'll be going through the types of flow sensors. We have narrowed them down into 6 major groups which work through different measurement concepts. The types are mechanical, volumetric, variable area, thermal mass, electromagnetic, and ultrasonic. Mechanical flow sensors. This sensor works based on positive displacement. The stream is divided into known volume parts. The force of the fluid flow drives the mechanism forward, and flow rate is taken to be proportional to rotational speed. This sensor is highly accurate, but has a pressure drop and is prone to clogging. It also requires a full pipe laminar flow. Here we have a few types of mechanical flow sensors. Firstly, the nutating disc, which wobbles to allow flow through. Next, we have the gear and turbine type, which rotates with the flow. Volumetric flow sensors. The main concept of this is pressure differential involving Bernoulli's principle. How this works is as fluid passes through the constricted region, its velocity increases. A higher pressure difference can be equated to a higher velocity flow. Thus, fluid velocity is able to be calculated with the pressure difference. The accuracy for this sensor is relatively high, with a few specifications. The flow has to be clean, turbulent, and constant. Now for a few examples. We have the pitot-static tube, orifice meter, and the Venturi meter. All of these involve a constricted region which allow for the pressure differences. Variable area flow sensors. The concept behind this is mechanical equilibrium. How it works is the float is pushed upwards due to the fluid, and the measurement tube widens towards the top, which increases its cross-sectional area. Eventually, the float stops moving as its weight is balanced by drag force. Thus, we are able to measure flow rate through displacement of the float. This flow sensor has moderate accuracy, and its specifications require a clean fluid with a high and stable flow. Here are two examples of this sensor type: the movable vane meter and the rotameter, both operating on the same mechanical equilibrium principle. Thermal mass flow sensors. The concept behind this one is heat transfer. A measured amount of heat is supplied to the fluid. The temperature upstream and downstream is compared using a sensor. The more heat lost, the greater the flow.
The accuracy of thermal mass sensor is moderate and needs to be calibrated with known thermal properties. It can only measure flow when the flow rate is constant and is at low pressure. Thermal flow meters should not be applied to abrasive fluids because they can damage the sensor. Fluids that coat the sensor can alter the relationship between the thermal properties of the fluid and the measurement, adversely affecting the flow measurement. A thermal mass sensor looks like this. The turbine sensor rotates perpendicular to the flow direction. Mutating disc wobbles as flow passes through. Magnetic flow meters use Faraday's law of electromagnetic induction to determine the flow of liquid in a pipe. In a magnetic flow meter, a magnetic field is generated and channeled into the liquid flowing through the pipe. Following Faraday's law, flow of a conductive liquid through the magnetic field will cause a voltage signal to be sensed by electrodes located on the flow tube walls. When the fluid moves faster, more voltage is generated. Electromagnetic flow sensors consist of two electrode and two solenoid coil. The flow of fluid induces a voltage between electrodes. Therefore, voltage is being amplified to stand output signal. As said before, electromagnetic flow sensors follow Faraday's law that states that the voltage generated is proportional to the movement of the flowing fluid. The electronic transmitter processes the voltage signal to determine liquid flow. The accuracy of electromagnetic flow sensors are moderate. It can measure the flow of conductive fluids which are at low pressure. Magnetic flow meters are often selected because they are obstructionless and cost-effective. They are mostly used for slurries and provide highly accurate volumetric flow measurement. On the other hand, they don't work on non-conductive fluids such as oils, as electrode can become coated. Ultrasonic sensor, otherwise known as sonar sensor, uses sound wave to determine the velocity of fluid flowing in a pipe. A sound wave is sent out at a specific frequency and the elapsed time for it to bounce back is recorded. The data is then used to calculate the distance between the sonar sensor and the object. At low flow conditions, the frequencies of an ultrasonic wave transmitted into a pipe and its reflections from the fluid are the same. Under flowing conditions, the frequency of the reflected wave is different due to the droplet effect. When the fluid moves faster, the frequency shift increases linearly. The transmitter processes signals from the transmitted waves and its reflections to determine the flow rate. This technology can be very accurate and is used for study of expensive fluids such as natural gas and petroleum liquids. It can handle extreme temperatures. Ultrasonic flow meters do not obstruct flow, so they can be applied to sanitary, corrosive, and abrasive liquids. Disadvantages include high costs, sensitivity to stray process vibrations, problems with pipe diameter change due to buildup. It can be used to measure low pressure drop and fluids that allow ultrasonic waves to pass.
Okay, hi guys, we'll be looking at some measurement principles. Alright, you'll be looking at the SI standard units, which is millicubes per second. Other units would include gallons per minute, liters per second, etc. But we'll be sticking to just SI units because it's just easier to calculate from. These are just some measuring principles: density, velocity, specific gravity, and pressure head. All of these units are all in SI units. These units can be used to calculate mass flow rate and volumetric flow rate. As shown, the unit for mass flow rate is kilograms per second, where density is multiplied by volumetric flow rate. Mass flow is the movement of fluid over time quantified to the fluid's mass. Volumetric flow rate is in millicubes per second, where surface area is multiplied by velocity. Volumetric flow is the movement of a fluid over time quantified relative to the fluid's volume. Alright, moving on, we'll be looking at some applications of flow sensors in the industry. Alright, so in chemical and petrochemical industry, an orifice meter is used to measure the flow rate of chemicals in pipes. In the medical industry, a venturi meter is used to measure the volume flow of blood through vessels. In aviation, a venturi meter is also used to measure the amount of speed of air around the plane. Waste in plant treatment facility or food and beverage industry is where a magnetic flow meter is used to measure liquid flow rate. Other examples would include ultrasonic flow meters used in sewage treatment, fuel and lubricant flow, which is used for food products like milk. For now, these are the questions. Is it better for a flow sensor to measure mass flow rate instead of volumetric flow rate, and why? And the other question would be, name a type of mechanical flow meter and an area in which it can be used in. Alright, thank you guys for watching our presentation. Hope it gives you some valuable insight into how flow sensors work and what they can do application wise. Have a good rest of the day. See you guys.